In this exercise, we will be looking at the basics of 2D lines and points. So let's get started. This is a planar projection and a frontal projection for a simple point. Okay, we've got the planar view, frontal view. Now we're going for the side view, and we will name our point A. So it's A in planar view, A first in the frontal view, and A second in the side view. Okay, we are drawing the coordinate system right now. Let's go for drawing this in axonometric as well. We're not going to do all the fancy axonometrics, just a simple isometric, so you understand how these volumes carry over from planar geometry to 3D geometry. So you are basically copying all the distances, okay, for frontal view, planar view, and side view, and those will generate our volume, our point rather, because there's no volumes here. The only thing that's kind of different here is that we will have projections. So we will basically project on the planes, right? That's the interesting thing. The point A, right, is defined by the planar projection, the frontal projection, and the side projection. Okay, that's what we're actually drawing in our triple projection, right? The frontal, the planar, and the side projections. We're using that to describe a volume. Okay, let's go for a line now. Let's see how that would look like. It's just a simple line. A simple line is generated by 2 points. Okay, and yeah, let's see how that works. Well, let's go for the side view, and obviously going to draw the line over there, just like that. We need to name the points, basically, that generate our line. Okay, so this is the coordinate system of x, or y, or z, or y second. And now let's name the points A, B, right? First and second for the frontal view and side view. Okay, let's go for the axo now. So we are basically going to be copying the projections, okay, the distances on the axes. So that's the first distance on the OX axis. Then we will go for the height. There we go. And then the side view. Okay, and let's construct everything. Just like that. Okay, let's measure everything up. Let's get those heights. And after that, this is our main segment. Okay, it's actually inclined. And you can tell that, right? Because it's inclined in the frontal view and the side view and even the planar view. But we will be describing it with the help of our projections. Okay, so let me just do that. Let me thicken these projections. And the coordinate system, of course. OX, OY, and OZ. Okay. So this is our segment. And I forgot to thicken the projections, right? This go and connect them just like in the planar view. Okay. Right, good. So let's see a couple more examples. So this is again a simple line. We will draw the side view as well, which is going to help us define it. Okay. So we are drawing these projections to help us identify our line. Right. And now let's draw a parallel line. How would that work? How would you get a line being parallel? Well, a line is parallel when it's projections, sorry, in all projections. So when its projections in all three views are parallel. So you see the frontal projections are parallel, the planar projections are parallel. Let's go for the side ones as well. See if those are parallel. And yeah, of course they are. Right, and let's construct these two segments in in basically a axonometric. You can call them lines or segments, it's fine. Basically, if they're segments, that means they're finite. If they're lines, they extend to, infinity. Okay, one moment. Just a short mistake there. These go the other way around, okay, because the rotation of our axo. Right, so let's thicken the axes, the coordinate axes. OX, OY, OZ, OY second. Right. And let's go and draw the axonometric. Actually, no. Let's jump to lines that are intersecting. We'll draw the axes after. So two segments are intersecting when their projections are intersecting as well. Okay, so if the planar view and the frontal view are the planar and frontal projections are intersecting, then these two segments are most definitely intersecting. Okay, because it has to make sense. If they, we will draw two segments that aren't intersecting, and you'll tell the difference. Okay, so let's go in detail with this, and then we will go for the axonometrics. Okay, let's thicken the axes. Okay, OX, OY, OZ, OY second, and let's draw our segments. P is the point of intersection. Right, so they intersect. AB, right, and probably a CD. Now let's identify these points. So that's segment AB, segment CD, let's copy that in the planar view, and then let's go for the side view where the intersection is going to be obvious. Right? Interesting. Okay. And let's thicken these segments. Right. Okay, and now let's go for two segments which aren't intersecting. Let me just move that OZ axis to the right. If they're not intersecting, that means their projections aren't intersecting. So what can you do? The frontal projections are intersecting, okay? But, as you will see, the planar ones, right, aren't. So the point where they would meet up in frontal view doesn't coincide with the point where they meet up in planar view. Okay, it's the bottom, the planar view one is on slightly to the right. Okay, so let's thicken these axes, right, and go for the side view, and you will see that they don't intersect. Just raise these heights. Okay, hopefully this is all making sense. It's a fairly logical approach. Okay, CD. And let's get all those points. As you see, the points don't really overlap. They're kind of there, but they're not. Okay? That means there's no intersection happening. The lines are, crossing by each other, right? They're not, cutting, so to speak. Okay, let's start drawing the axo for each of these particular cases. So first, for the parallel lines, let's copy those segments from the planar view and the frontal view, and we will copy them and chuck them in the axo. Right, that's the easiest way to get this done. And yeah, just slow but steady, copy everything, throw it in there. And then copy the heights and measure up our segments properly. Right. Okay, let's measure up all the projections. We will copy them from the axonometric, from the triple projection right at the axonometric. So we are measuring heights right now, and heights for the frontal view, for the side view. And point by point, we will identify these segments. Their projections need to be parallel, as well as the segments themselves. Okay, let's see how we can do that. So if we get all these segments together, so to speak, right? So get the projections together, we can then connect them up and generate a segment. Okay, simple as that. Okay, so by using all three coordinates, we can find out the real points. And yeah, those will generate our segments. And then we'll thicken them and obviously thicken the projections as well. And double check if our drawing is correct, then the segments are parallel and the projections are parallel as well. Okay, let's see. My point. Right. So let me just identify the last part of the second segment. And we'll connect everything up. Now forget the lettering is very important, so the final point would be like a A. The horizontal projection is a small a, and the frontal view is A1, A first, right? And the side view is A second. Okay, let's connect everything up. And these should be our segments, and they kind of look accurate, they look parallel. Okay, if they look parallel, then it's all good. Okay, let's see. Right. And let's finish these projections. Thicken the projections as well, and that's going to generate our volume. Okay, good. Let's see, AB and CD. Right, these are projections. Let's color them with dark blue, just to make them stand out a bit more. And then we can go for the next axo, which will feature two lines intersecting. So the thought process is 100% the same. We are copying the projections. Okay, so if we're looking at these descriptive geometry assignments through the 95/5 lens, okay, the 5% that really matters is obviously getting the right dimensions and understanding that, you know, the properties that you describe in the planar view need to, in the triple projection, so planar, frontal, and side view, need to carry on to the axonometric. So for our two segments to intersect, they need to intersect in the axo, and also their projections need to keep intersecting. Okay, so you really also need to understand that in the triple projection, that's why it's called a triple projection, because you've got three projections. You're just drawing the projections, you're not drawing the volumes themselves. But fortunately, those projections are enough to describe the segments in 3D. Okay, let's see, I'm thickening the coordinate system just to get a bit more clarity. Keep it in mind, you really need your graphics to be on point here. And these are technical drawing graphics, which basically sum up to you having a very clear and crisp line drawing with clear construction lines and clear, contour lines and so on. Right, CD and AB need to intersect. There we go. That's the point of intersection in the projection, and that needs to carry all the way through to the final axo. Okay, so it's just a matter of identifying the points. Don't forget to name them correctly. right? So A for planar view, A first in the front view and A second in the side view. Okay, let me just thicken those coordinate axes in our first axo. So yeah, right, you say what you will, but this looks good. This looks like a proper technical drawing. Okay, with a lot of lines. Okay, so let's connect all the other parts up and get our volumes together. Right, they need to intersect in all projections. There we go. Right, P is the intersection point. We can start, obviously, coloring. Optional, but you can thicken them or color them, whatever approach you like. The projections, so we can bring them in the axo, and hopefully they'll intersect there as well. I really don't see a reason why they wouldn't at this stage, and that's going to generate an accurate drawing. Okay, good. Let's bring all those points together, right, to generate our intersection. Okay, these are our segments with a point there. And now let's go for the final two segments, or lines, if you will, which need to not intersect. So basically they'll look in the axonometric as though they're passing by each other without intersecting. Okay, as I said, it's not as obvious in the triple projection. It's going to be very obvious when we are drawing the actual lines in axonometric. Okay, don't forget to measure the correct lines. And yeah, let's copy them as fast as possible so we can get to the interesting part where we are drawing our segments. Okay, parallel there. Let's do all these parallels from one go. Graphics-wise, remember to always keep your drawing tools tidy. This way you'll minimize smudging. Also, yeah, literally go and wash them from time to time. That's one thing. And another thing could be, pressing on the pencil just with the, basically with the weight of the pencil itself. So don't press on the pencil too much because it's going to smudge. Okay. There we go, point by point. Really nice. Okay, see how these segments look like. Nice side view now. Right. Right. So point by point, side view. Again, the lettering is essential. Just go for the simple letter in the planar view, the simple letter with a little dash in the first view, and with two dashes in the side view. Like a minute and second. Maybe there's another standard way you live in, right, of representing this stuff, but to be honest, I think this is the best one. Okay, just to describe everything. And if you're doing a planar change, you're changing the index of the coordinates. So they're 1 and 2. So O1, X1, O2, X2, and so on. And the points are A1, A2. Right, so this should be one line. Right, and let's see the other one. Obviously, let's finish the projections first. Yeah. So they're colored in blue, just to make them stand out for a bit. Right, connecting everything up. Yeah, so that's one segment, and let's draw the other one as well. Whoop. Let's see how that works. So that's one segment and that's the other. As you see, they're passing by each other, right? They're kind of deformed because of the way the axle works and the incline and so on. Right, let's go to specific lines. Okay, we need to do a couple of exercises with specific lines. So let's draw a horizontal line. A horizontal line is in a horizontal plane, so it's parallel to the XOY plane. It can be rotated at any angle, don't get me wrong, but it's still parallel. So that means its frontal view and its side view look like, right, like horizontal lines. There we go. Let's name this. And we'll see if we go for the axo now or the axo later, whatever. We've basically got 3 parallel lines and 3 perpendicular lines. Okay, so one for each plane. Parallel with the frontal plane, the side plane, and perpendicular on the horizontal plane, perpendicular on the frontal plane, perpendicular on the side plane. Okay, so this is a horizontal line. Okay, next up, let's draw a line which is parallel with the frontal line. Okay, so this line is going to look something like this. Okay, and it will be called a frontal line. Makes sense, right? It's frontal. You see it from the front. You can't see it from the top or the side. Okay, same thing. Noting the points, noting the segments. Okay, this is fairly linear. It's going to help you make sense of descriptive geometry a bit more. Right? You delve a bit deeper in the theory. Okay. So frontal line. Next up, that's kind of close. We need to move the reference system to the right. Let's draw a line which is parallel to the side plane. So how would that be called? Because you see its profile, so that's a profile line. Okay. You can't see it from the front, you can't see it from the top, you can only see it from the side. Okay, very good. Right. So let's name the points, and then we will maybe go for the axos. Okay, this is making a lot of sense. It's very, linear in thinking. So a profile line that you see only from the side. Right, so let's go for the axonometric for this. So basically just copying the projections and constructing our segments, or lines if you rather. They are segments the way I drew them, but you can obviously extend these segments so they form lines. Okay, a line is infinite. A segment starts from one point and ends in the other point. Okay, let's see. Slow but steady. There are all sorts of applications for this stuff. You'll see this in tangency exercises and stuff like that. But again, you don't want to basically get stuck in over-analyzing this stuff. The end objective is to get problem-solving capacities with your descriptive geometry skills, okay? So you want to learn to solve complex, or as complex as possible, descriptive geometry situations, right? You don't want to be able to name them in your sleep. It's not, grade school, it's real life, it's design life, okay? You need to combine these ideas together. Like these, all these lines could very easily be, radiuses for tangencies, for stuff like that. Okay, so that's our segment in the axo. Right, let me just finish this off. Finish this axo. Got a couple of lines left for the side view. Okay, very good. Let's just add everything in here. Right, and this is how our segment looks like. let me just thicken the projections and the coordinates, and then we are good to go for the next set of lines. Obviously, after this, we will go for the perpendicular ones. Okay, good. Very good, let's thicken everything. Okay, let's go for the next one, the frontal one. Again, same mindset, copying the dimensions of our projections. Okay, and yeah, taking it from there, seeing how it all connects. Right, let's copy those heights. Okay, very good. So point by point, you see my points, the way I'm drawing them, they're not like random marks, they're like little dots. Okay, I'd really like to stress this out. Always do your best to get this clear graphic, right? This clear graphic technique. Draw all your points just like what they are, dots. Okay. Okay, let's see. The side view. Let's draw the coordinate system now. Right, let's mark these segments. B second, A second, right, good. And yeah, just thicken the segment a bit and add the proper lettering, and then move on to the next. Oh, I forgot to add the lettering, imagine that. Happens from time to time. Okay, so let's go for the profile one now. The profile line. Again, same thing, we are copying the distances. There we go. Again, you will make mistakes in descriptive geometry, but that's 100% fine, because you will obviously correct them when need be. Right. Let's get the other dimensions as well and add them. Okay, very good. Right. So this is going to be our profile line. Okay, you just see it like from the side. You can't see it frontally or from the top. It just looks, I mean, you can see it, but you don't see it in real dimension. That's what I mean to say. Okay, you obviously can look at a horizontal from the frontal view, and yeah, it's a horizontal, it's there, but you can't tell the incline, right? You can't tell the real dimensions. Okay, let me thicken these last coordinates. Okay, and then we will go for the last 3 lines. Okay, OX, OY, and OZ. Very good. Okay, the interesting part. So lines can be parallel to these planes, or they can be perpendicular. So question, what is a line which is perpendicular on the horizontal plane? Right, a vertical line. Okay, let's see. Obviously, they can have, I mean, I doubt it, but they can have different names around the world, okay? But the principle is 100% the same. So for a vertical line, you can just go on and basically draw it like a vertical line in a frontal and the side view, and there's a dot in the planar view. Okay, because it looks just like a dot. The lines overlap. Right, let's go for the perpendicular on the frontal view. All right, vertical. Next up, perpendicular on the frontal view. Well, where I studied, they call this a end line, right? Because it's, I don't know why, to be fair, because it's ending on the frontal view. Maybe that's the way, that's the mindset. Okay, regardless, it's a line perpendicular on the frontal view. Okay, if you remember when we are drawing a descriptive geometry assignment with, let's say, a tetrahedron, it needs to have one edge which is always perpendicular on the frontal view, because it's going to help you generate that a specific position. Okay, well, what is that? That's an end line, one of the equal triangles, which is the base, is going to be an end line. Okay, and for the perpendicular on the profile line, on the side plane, sorry, well, they usually call this a frontal horizontal line. Okay, because it's frontal and it's horizontal at the same time. Okay, so it looks like a line, a perpendicular line in the frontal and the planar view, and as a dot in the side view. Okay, this is fairly simple. We'll just draw the axonometrics for all three, and then obviously copy paste the dimensions, and then that's it. But don't forget, all these lines, when you have one line, it's just one line. Okay, it's fair enough. But what happens when you have multiple lines? They can generate a plane, right? So there you go, you've got planes which have the same properties. Horizontal plane, vertical plane, frontal plane, profile plane, end plane, right? Frontal horizontal plane, and so on. Okay? Food for thought, because we will be tackling those planes up next. Okay? But let's get through this as fast as possible first. I mean, not as fast as possible, but you know, it's kind of boring, to be honest. This is a boring part of descriptive geometry. Okay, good. So let's draw everything. Obviously, all the projections overlap, the horizontal projections. And let's draw the reference system next, and move on to the next line. Right, okay. So let's copy that. Okay, again, copying the dimensions from the triple projection. You can obviously start measuring these lines, but you see it's just pointless mental effort. Just focus on copying them on an A4 paper, and you know, keep that mental effort for mental energy, for mental effort, for a more productive task, I would say. Like maybe a more complex descriptive geometry assignment. We shall see. Right, so this is the end line. So it's perpendicular on the frontal view. Let me draw the projections and thicken the coordinate system, and then that's it. Okay. Right, very good. Let's go for the last axonometric. Okay, let's copy everything, and again let's measure up, and let's draw that frontal horizontal line. Okay, so a line that's frontal, it's parallel to the horizontal plane and to the frontal plane at the same time, so it has no choice but to be perpendicular. Okay, good. So that's going to be our line, and let's draw the projections as well. Okay, so this is a lot of information, which is very good to have. Go through these exercises once in your career, and then you're set. You've got them there. You know how to use them when you need to apply them. Okay, it's like riding a bicycle. Okay, so marking the points, the projections. There you go, a bit of overlap. So that's a end line. All right, and that's a frontal horizontal line. Okay, next up, planes.